When talking about the depths of our ocean, some people tend to think of a barren stretch of mud or rock with nothing else in sight. An underwater wasteland, so to call it. These people, however, could not be more wrong. The depths of our oceans contain such a fascinating and surprisingly diverse ecosystem that scientists today are still amazed with what's being discovered. And the deeper we go, the more we get surprised by the fact that life somehow finds a way to cope in these unforgiving conditions. But surely there has to be a limitation on the depths life can be found. Surely there must be a depth where no life can live in. Well, in today's video, we will be exploring the deepest areas of our world, and what types of life can survive there, and how they're adapted to survive in those environments. Today we'll be answering the question, how low can life go? Our ocean is split into 5 different zones based on depth. From the surface to the very bottom you have the epipelagic zone, the mesopelagic zone, the bathypelagic zone, the abyssopelagic zone, and the hadopelagic zone, which in English translates to the sunlight zone, the twilight zone, the midnight zone, the abyss, and the hadal zone. Today's video will mainly focus on the last 3 zones, with more focus on the abyss and the trenches. The bathypelagic or midnight zone is in a constant state of darkness, where the only light that is seen down there is the light produced by its inhabitants. An example of this is the well-known anglerfish, a bathypelagic fish that's specifically adapted to take advantage of the darkness it lives in. Protruding from its head is a lure that produces light due to a symbiotic relationship with bacteria that can produce this light. Its prey are drawn towards the light and by extension the mouth of the anglerfish. Because of this adaptation, the anglerfish does not have to actively hunt its prey, as it would prove difficult considering the conditions it lives in. Marine mammals, such as dolphins, seals and whales, cannot live in the deep waters, as it is too far away from the surface of the water to breathe. But some whales can dive to impressive depths to hunt for food. For example, the sperm whale, the largest toothed whale in the world, can dive to a depth of 2,000 meters to hunt for giant squid. However, this hunting period is short, for only about 90 minutes at a time, then again compared to humans that's quite long. The second largest toothed whale, the curvius beak whale, beats the sperm whale by diving up to 3,000 meters in the 2-hour time frames to hunt fish, making it the deepest living mammal in the world. However, although these depths are impressive, there are countless other animals that live deeper. Another example of a bathypelagic animal would be the lanternfish, a fish that has ended up making up 65% of the ocean's fish biomass, making them the most populated marine animal in our seas. They get their name from the bioluminescence they produce, which can help them avoid predators, as when they look up for silhouettes of the fish, the light they produce counteracts it and masks their shadow. Eels can also live in this zone. For example, the gulper eel, a fish that's jaws consist of a quarter of its body, compensates for its lack of food by making the most of what it can when it does. It can swallow prey much larger than itself, although it prefers smaller food such as crustaceans and shrimp. This lets the eel take in vast quantities of nutrition to keep it going longer until it finds more food. Almost all deep-sea fish have extremely low metabolism rates, as food is scarce in these unforgiving depths that they cannot afford to waste energy. This zone is also where the deepest living shark lives, known as the Portuguese dogfish. These sharks tend to actively hunt prey such as fish and cephalopods, using their keen sense of smell. These sharks are found almost worldwide and takes the title as the world's deepest living shark, only just taking that spot from the frilled shark. These are just some examples of some of the animals that can make up the deep sea ecosystem, but if you want to find the deepest life, we'll have to look further down, into the abyssopelagic zone. Now this is where things start to get juicy. The abyssopelagic zone consists of depths from 4,000 meters to 6,000 meters, leading these waters to temperatures of approximately 2 to 3 degrees centigrade, causing most life there to adapt to conserve energy in this harsh environment. Without access to sunlight, photosynthesis can't take place, so therefore the floor of the abyssopelagic zone is devoid of most plant life, causing the food chain to act slightly differently. Organic matter from dead sea animals sinks to the bottom of the ocean in particles called marine snow. These particles are eaten by scavengers, and thus the food chain continues as per normal. Marine snow isn't the only form of sustenance found for scavengers here, however, as carcasses from larger animals such as whales tend to fall, starting mass feeding sessions from organisms all around. However, the reason we're investigating this area of the ocean isn't because of the amazing way life manages to survive here, it's the animals that live here and to what depths they can survive at. A good example of this is the octopus genus Grimpoteuthis, also known as the Dumbo octopuses, located in the abyssopelagic water around New Zealand, Australia and the Philippines. Named after their large fins, these octopi use their fins to propel themselves through the water and use their arms to steer them in the right direction. This allows them to be able to swim for long periods of time, as the pressure from jet propulsion momentarily stops the beating of the heart of the octopus, thus meaning it can't use it for long periods of time. This adaptation also helps to conserve energy until they can find their prey, which usually consists of small invertebrates on the seafloor. Other examples of life down here include the tripod fish, a fish with small appendages on its lower body that help stabilise it while scouring the ocean floor for prey. As it can't see, it relies on currents and its front fins to aid it eating prey. The currents carry crustaceans and smaller fish towards it, and it uses front fins like hands, making sure they're edible or not. If they are, they're knocked into the fish's mouth to be digested. Once again, the process of letting the prey come to you, as opposed to the other way around, has led to the tripod fish being able to conserve energy, which will help it survive longer without food. Though all these deep sea animals are interesting, believe it or not, there is another level to the ocean, deeper than the abyssopelagic zone, which only the most adapted extremophiles can survive in. Now it's time to find out how low life really can go into the Hadal zone. The Hadal pelagic zone consists of the deepest points in our ocean trenches, 6,000 meters and below. Hadal trenches account for about 0.25% of our ocean's floor, yet somehow they still manage to support life in the crushing pressure, lack of sunlight, and hard to see warmth. So what kind of life can survive in this ecosystem? This deep in the ocean, life can only be sustained by one of two things: the marine snow, which we talked about earlier, and the chemical reactions produced by the hydrothermal vents that can sustain the life that crowds around them. Not many fish tend to live in these hostile environments, but some do seem to manage down there. For example, the pearlfish is a parasitic species that tends to live on or inside invertebrates or sea cucumbers. With food being such a scarce commodity in the Hadal zone, this is seen as a wonderful adaptation to survive, as once they find a host, they're practically set for life. Another example of one of the deepest living fish in the world includes the Mariana snailfish, a fish found to live in, you guessed it, the Mariana Trench. Snailfish in general resemble the appearance of a tadpole, and are probably the most dominant fish species found in the Hadal zone. The Mariana snailfish has been observed at depths of almost 8,200 meters deep, making it the second deepest living fish ever observed. Little is known about their behavior and feeding habits, except they have been observed to feed on crustaceans such as shrimp that live down there with them. However, the Mariana snailfish is not the deepest living fish on planet Earth. That title actually goes to Abyssopelluta galethi, a species of cusk eel discovered at the bottom of the Puerto Rico Trench at a depth of around 8,370 meters, giving them the first place award for the deepest fish ever discovered, at least for now. There may be more species of fish yet to be discovered that live deeper, so until all of our oceans are explored, we will never truly know. There's still plenty of life that's been discovered far deeper than the fish we've already discussed. For example, deep sea gigantism, a phenomenon related to the pressure of the deep oceans, has caused some creatures to grow in size to be able to survive the hostile environments that are thrown at them. For example, Hirondalia gigias is a species of amphipod, basically a shrimp, that has been observed at sizes much larger than that of a normal amphipod. Discovered in Challenger Deep, the deepest point in our planet in the Mariana Trench, at a depth of 10,994 meters, scientists have been shocked as to how it could have grown to be so large. As for it being a scavenger, food is vastly scarce, especially at a place so deep. This comes to show how much mystery and surprise our oceans still have to throw at us. Other life forms have been discovered in Challenger Deep, such as bristleworms and sea cucumbers. Now I could go on for hours about all the different life that lives down here and what the deepest living types of creatures live here, but I won't. So finally, after 1,932 words, it's time to finally answer the question of how low can life go? Well, compared to everything else described in the video thus far, the answer's actually pretty generic. It's microbes. During expeditions to the deepest points of Challenger Deep, hundreds of species of Foraminifera, a type of eukaryotic cell, were collected and analysed. And that's it. That's the lowest humans have seen life go. See, there's no solid answer to how low life can go, because we haven't explored the entirety of our oceans yet. There may be points deeper than Challenger's Deep yet to be discovered, probably full of life we've never even seen before. Even at places we've already discovered, there may be life deeper than we know. This goes for places we've already been exploring, such as Challenger's Deep in the Mariana Trench, where there may be fish or crustaceans never before seen that break the record others of their kind have set. Technically, I've actually answered the question, how low has life been observed to go, and not the answer to how low can life go. So basically, to answer the question of the video, the answer is, we don't know yet. There it is. After all that, all 2,000 plus words, there you go. There is no answer. So thanks for tuning in, and I hope your learning experience was as good as mine.